All right, today we're going to tackle a huge challenge, one that anyone working in science or data analysis knows all too well. How do you manage enormous numerical data sets without completely losing your mind?
So, does this sound familiar? You've got data, and I mean a lot of data. We're talking gigabytes, maybe even terabytes of critical information coming from simulations, experiments, or big models. And you know what? It's only getting bigger. Trying to manage these massive data sets can feel like you're trying to organize chaos. But let's be real, a lot of the time it's just chaos. It feels like you're just drowning in files, struggling to even keep track of what's what.
And that chaos, man, it leads to some serious headaches, right? You're sitting there waiting forever for a massive CSV file to load, or maybe you're juggling like thousands of different files for just one project, and you find a file from 6 months ago and, whoops, the metadata's gone. You have no idea what you're even looking at. Sharing that data with a colleague, it's a total nightmare. And maybe the worst part, you just need one tiny slice of data, but you have to load the entire gigantic file just to get to it. It is just so inefficient.
But what if? What if you didn't have to deal with all that? What if there was a file format that was built from the ground up to solve these exact problems?
Well, guess what? There is. It's called HDF5. That stands for Hierarchical Data Format version 5. And it's not just a file format, it's a whole library. And its entire job, its reason for being, is to store and organize just massive amounts of numerical data and do it efficiently.
Now, if you remember one thing from all of this, let it be this quote. The best way, the absolute best way to get your head around HDF5 is to think of it as a complete file system, with folders and files, but it's all tucked away inside one single file on your computer. Okay, so a file system in one file? What does that actually mean? Let's unpack that analogy because it's pretty powerful. So this slide really breaks it down. We're just mapping the stuff you use every single day to the HDF5 world. So the folders on your computer that you use to organize everything, well, in HDF5, we call those groups. The actual files that hold your data, like your spreadsheets or text files, those are called datasets. And all that extra info, the properties of a file, like when it was created or who made it, HDF5 calls that attributes. See, it's the exact same logic you're already used to, just contained in one neat package. So yeah, these are the three core pieces you need to know. Groups are your folders. They create that hierarchy, that structure. Datasets are where the raw numbers live. Just think of them like giant NumPy arrays. And then attributes, that's the magic metadata. It's the labels and notes that explain what everything is, which makes your data files completely self-describing.
Okay, so being organized is great, for sure, but HDF5 has a few other tricks up its sleeve that make it incredibly fast. Let's call them its superpowers. Let's go back to that performance issue for a second. With a typical file, your data is just one giant, continuous block on the disk. So if you want to read a single row from the middle of a terabyte-sized file, the computer often has to read all the data that comes before it. For a huge file, that is a colossal waste of time and memory.
HDF5's solution to this is just brilliant. It's called chunked storage. So instead of having one massive, indivisible block of data, it breaks everything up into these smaller, much more manageable pieces. And we call them chunks.
And what HDF5 does is it runs these chunks through something called a filter pipeline. It's a pretty cool process. First, it splits the data into those chunks. Then it can apply a filter, like something called shuffle, which cleverly reorders the bytes to group similar values together. Why? Well, that makes them way easier to compress. Then it applies a compression filter, like gzip, which shrinks the chunk down. Finally, that small, compressed chunk gets written to the file. So now, when you need some data, you only have to read and decompress the specific chunks you need. It saves a ton of time and disk space.
Okay, so we've got this amazing organization and these incredible performance superpowers. But what's the real payoff? What does this actually mean for you, the person who's in the trenches working with all this data?
Well, this is where it all comes together. Because of those attributes, your files are self-describing. You'll never lose context again. The format is a universal standard, which means you get interoperability. A file you write in Python can be opened in C or MATLAB, no problem. Thanks to that awesome chunking we talked about, you get incredible performance. You can slice into massive data sets almost instantly. And of course, that whole hierarchical structure gives you real organization. You can literally replace a folder with thousands of messy text files with one single, clean, efficient HDF5 file. It basically solves every single one of those pain points we talked about at the beginning.
So, the next time you find yourself staring at a folder with 10,000 CSVs, or just waiting and waiting for a gigabyte file to finally load into memory, I want you to ask yourself this question. How could all of this chaos, your biggest, messiest, most complex data set, fit into a single, smart, self-describing file? Because with HDF5, that's not just a hypothetical question, it's the whole point.